Now let's again consider the data. We have the original frequency distribution. The operational months are given. 100 was the upper limit for the first class, 200 was the upper limit for the second class, and so on. So if I make a frequency which is known as cumulative frequency, so I write here CF, cumulative frequency. So for the first class, it is equal to, okay, 57. That's fine. But for the second class, we have to see how many components have performed up to 200 months, right? So in this case, all the components in the previous class, they must be added. So I write it in this fashion. It is equal to the previous value plus value from the current class, right? So it will be added to 77. Then how many light bulbs have performed up to 300 months? So for this case, all the previous frequencies must be added. So now I can perform all these calculations in automatic form, and it will finally saturate up to 100, right? That all bulbs have performed a life up to 900 months. So this cumulative frequency distribution is also known as the ogive representation, ogive curve. Similarly, we can make a relative cumulative frequency, So that can be computed by normalizing it to 1, and that is possible by dividing the data frequencies by the total number of objects that were subjected to the lifetime testing. So it is here at $25. So again, we have got a representation that saturates to 1. And that is the concept we will relate with the probability concepts. And now the graph that we select for showing cumulative frequency and relative cumulative frequency, they are also important. So I select a graph from XY scatter and I join them with the straight lines. Select data, X values, and Y values are the cumulative frequency values. So this is known as an ogive curve, smooth frequency curve. You are allowed to join the data points at the end of the interval. So it saturates at a value equal to the number of experiments. The other graph is for the relative frequency distribution. X values, well, it's Y values from the relative frequency. Okay. So we have got a similar curve. However, it saturates up to 1. It is the relative cumulative frequency distribution, and it is also known as probability distribution function. You can fit an expression to that one.